Welcome. Here, we break down complex electrical engineering concepts into simple, practical, and engaging explanations. So stay connected with the world of electrical engineering.
First, imagine the innermost part of the bushing, a solid metal conductor, a copper rod or tube running through the center. This rod carries the high voltage current from the transformer winding out to the line. Around this metal rod are many layers of insulating material. In each layer, a sheet of aluminium foil is sandwiched between layers of dry kraft paper. Think of each foil paper sandwich as a little capacitor. All these capacitors are stacked in series, which makes the voltage drop evenly along the bushing. In other words, the grading foils help spread out the electric stress so that no single spot holds too much voltage at once. Next, after wrapping all the paper and foil layers, the entire core is vacuum impregnated with epoxy resin. In practical terms, the assembly is put into a vacuum to remove air, and liquid resin is drawn in to soak all the layers. The resin then hardens into a solid block of insulation. The big advantage of this solid insulation is that it is completely dry and very strong. There is no oil inside, so there is no danger of oil leaks or fire. The solid resin also binds the layers tightly, resulting in very low energy loss. For example, our IP bushings have a tan delta dissipation factor on the order of only 0.35% or lower, which means very little energy is lost as heat in the insulation. Finally, the hardened core is placed inside the outer insulator housing and secured with a mounting flange at the bottom. The bottom flange is grounded to the transformer tank, often containing SF6 gas or oil, while the top protrudes into the outside air. You will notice a small test terminal called the tan delta test tap on the bushing. It is connected to one of the foil layers. This test tap lets technicians measure the capacitance and tan delta of the bushing. In simple terms, it's how we check the health of the insulation. If the tan delta value goes up during operation, it tells us that moisture or damage has crept into the insulation, a sign of deterioration. In summary, a RIP bushing is built from inside out. A central conductor, then many paper and foil layers for voltage grading, all locked solid with epoxy. Because there is no oil, RIP bushings are much lighter and operate at higher temperature ratings, class E. They also need almost no maintenance, no oil to top up, and will not catch fire or explode like an oil-filled bushing. These features, together with the even voltage grading and built-in tan delta testing, make RIP bushings very durable and reliable in modern power equipment.
Thanks for watching. We hope this video helped you understand electrical engineering concepts better. If you enjoyed the content, don't forget to like, share, and leave your thoughts in the comments. Stay with us and stay updated with more videos on transmission lines, substations, and power systems. Until next time, stay curious, keep learning, and keep the power flowing.